While individually the exponent rules themselves are not that complicated, when you start putting them in combination with each other, they can get pretty complicated pretty quickly. Here's an example we're going to take a look at. X to the fourth, y to the third, raised to the second power, times x, y to the fifth, raised to the fourth power, divided by x to the third, y to the fourth, raised to the second power. Now, there are quite a few different ways to go about dealing with this scenario. What I would do first is to start by looking at the places where you have a power raised to a power. Now, if you figured out your shortcuts, you should know that if we have x to the fourth, and we're going to raise that to the second power, we're going to have x to the fourth 2 times, which means that we really just have x to the 8th power. 4 x's done twice is 8 x's. Then the y to the third, we have 3 y's done twice is going to give us 6 y's. The second set of parentheses there, x, y to the fifth raised to the fourth, we have x done 4 times is going to be x to the fourth. And then we have y to the fifth, so 5 y's done 4 times. Well, if we have 5 y's and repeat that 4 times, it's going to be 20 y's, so y to the 20th. The denominator, we can do the same thing. X to the third, y to the fourth raised to the second. Well, if we have x to the third and we do that twice, 3 2 times is going to give us 6 x's. So that's x to the sixth. And then y to the fourth raised to the second. So if we have 4 y's and we do that twice, we get y to the 8th. Now here's where you have some options as to what to do next. Personally, I like to look at the numerator and denominator individually at this point and decide, is there anything in the numerator that can be put together? If so, that's what I would do next. So looking at the numerator, I noticed that there are a couple of x's. We have an x to the 8th, and we want to multiply that by an x to the 4th. Well, 8 x's times 4 x's means that we're going to be multiplying 12 x's. So that's x to the 12th. And then I noticed that we also have some y's. Y to the 6th multiplied by y to the 20th. Well, 6 y's multiplied by 20 y's means that we end up with 26 y's. This is where the shortcut comes in handy because we don't want to actually have to write out and then count all 26 of those y's. In the denominator, there's nothing there that can be combined. So we simply have x to the 6th, y to the 8th. Now we look at the division part. X to the 12th of y to the 26th divided by x to the 6th, y to the 8th. Well, in the numerator we have 12 x's, and then in the denominator we have 6 x's. So if we think about 12 x's divided by 6 x's, and every pair of x's that can be divided out, it's going to leave us with 6 x's left. So x to the 6th, and then the y's, we have 26 y's divided by 8 y's. So if we take the 26 y's and divide out 8 of them, it leaves us with 18 y's. So y to the 18th. So the final answer here is x to the 6th, y to the 18th. We'll take a look at one more example. This time we're going to have x to the 3rd, y squared, raised to the 4th, times x, y, raised to the 3rd, over x to the 8th, y, raised to the 5th. I would approach this the same way. Anything that has a power raised to a power would be what we deal with first. So x to the 3rd raised to the 4th means we're going to have 3 x's 4 times, so that would be 12 x's. Y squared raised to the 4th means we're going to have 2 y's 4 times, that's y to the 8th. The other piece in the numerator, x, y to the 3rd. So we're going to have x 3 times, and we're going to have y 3 times. In the denominator, x to the 8th y raised to the 5th power. So we have x to the 8th 5 times, that's going to give us x to the 20th. Y 5 times would be y to the 5th. Now in the numerator we have some things that can be multiplied. x to the 12th times x to the 3rd. So 12 x's multiplied by 3 more x's means we multiply 15 x's. Then we have y to the 8th and y to the 3rd. 8 y's multiplied by 3 more y's means we're multiplying by 11 y's, so y to the 11th. And then the denominator, where did I get 20 from? This should have been 40. X to the 40th. Our denominator is x to the 40th, y to the 5th. Now we can simplify. We have x to the 15th divided by x to the 40th. Here's where you have a couple of ways you can think about this. One way is to use our shortcut. X to the 15th over x to the 40th, we can take those exponents and subtract them. Well, 15 minus 40 would be negative 25. So that is x to the negative 25. And then y to the 11th divided by y to the 5th, well, 11 minus 5 is 6, so that would be y to the 6th power. And then if we remember our definition of negative exponents, because we don't typically leave a negative exponent in our answer, a negative exponent means the reciprocal of the base. So the base of this piece is x. That means that base x, the reciprocal, is going to take it to the denominator, and we still have our exponent 25. The y has a positive exponent, so we don't need to take its reciprocal, it stays in the numerator. Our final answer then is y to the 6th divided by x to the 25th.